Thank you very much. Thank you for the introduction and welcome everybody. So, as mentioned, my name is Daniele and I'm an Android developer. I work for Novoda, which is a software agency based in London, but with several offices across Europe. Okay. Yeah, what Roberto is trying to say that we are going to introduce you to our project. It's a project that we work together in our spare time, and this is going to be the first part of our presentation. After lunch, we are going to have another talk. This one is going to focus a bit more on the hardware side, because we build an actual thing, which I actually have in my backpack. I forgot to put it out. In the next talk, we are going to talk about more about the software part. So we will see what we did on that side. But let's go on and explain what is this project. So this summer, me and Roberto collaborated creating this project for a very important event, which was his wedding. So he just got married in September, and we were preparing a selfie booth. So the idea was to create a device where people, attendees to this event, could take some pictures, some selfies like we usually like to do, but having a physical station where people can put themselves in a frame, take a picture, and share that picture with all the people participating to the event. The core of this device was Android. We will see later is, in particular, was Android Thing, which is a particular version of Android. Everything started when the user triggered the action by pressing a big red button. We will see later we choose a button that made it immediately clear what the user needed to press to start it. As soon as the button was pressed, a countdown was displayed on a monitor so that people had some time to put themselves into the frame to get in the right position, to start smiling, all these kind of things that we used to do when taking pictures. Then the picture was actually taken with an hidden camera, and the picture was stored as a JPEG file in the internal memory of the device. Then, when we have internet connectivity, we were uploading all the pictures to a Google Photos album. Google Photos then allowed us to instantly share for free the picture with all the attendees to the event. So without creating any push notification system, without creating any backend, we were already able for free to notify all the people in the event that a new picture was taken. And then they were able to see them that immediately in their devices. So, as I mentioned, everything started with the trigger, which for this use, we used a very big red button. When you can see this one, the first thing you think about is to press it. And that's what we wanted. We wanted people to immediately think about, I want to see that what's happening when I press that one. It was a normally closed button. Why it's important to say that? It's important because depending on the status, a normally closed or a normally opened button gives a different input to the board it's connected to. In case of normally opened, the circuit is not closed, so the current is not flowing if you are not pressing it. It's flowing, so the circuit is going to be closed when the user presses it. The opposite is true for a normally closed one. This is the diagram of the very basic circuit we had to do in order to make it work with Android things. As you can see here, this board is a Raspberry Pi, and how many of you already used or know what it is a Raspberry Pi? Okay, a few of you. For the others who doesn't know, a Raspberry Pi is a development board similar to Arduino, but way more powerful, which is also able to run Android things, as we will see later. Of course, for a selfie booth, we needed a camera. We needed a way to take the actual pictures. And for that, we used the Raspberry Pi camera module, the second version of it. We chose this one because it has a very good sensor. It's a true 8-megapixel sensor, which was able to take pictures even in low light, with a decent quality. It's comparable to a medium-range smartphone, for example. One of the first obstacles we saw while developing this was that Android Things was not powerful enough to render a smooth live preview. So if you think about your phone, when you are going to take a picture, you can see on your screen immediately what the camera is seeing. So you have a fluid video, let's say, of what is going to be taken, and when you press the button, that screenshot is saved. Android Thing is not that powerful yet. So what we need to do is to use a workaround for this.
So the workaround that we used was based on how we wanted to make our project look. So since we were using a large 21 inches screen, we tried to use a two-way mirror paper on top of it. So when the screen was switched off, you could see yourself in a mirror, and when the screen was switched on, you will see the content of the screen. And this is actually how it looks like.
This is an example of a mirror that I made for another event. And as you can see myself reflected here, but you can also see the text because there was a tablet behind it. It's the same principle that you can see in police movies when they are interrogating somebody and the people in the dark room cannot be seen from the other side because there is the mirror. The same principle. While on the field, while we were at the event, we wanted to have a way to know the status of the device. We could, of course, have used the big screen, but that one, we wanted to keep it just as a mirror so that the people could see themselves and use it. So we used this board, which can be connected on top of the Raspberry Pi and gives us some possibilities. It's a board which is called Rainbow Hat, like it's written here, and gives us some digit display, some buttons, some LEDs. It was good to get some indications. So we used it for very, very basic things. For example, showing if there was a network error, an authentication error, which we will see later why it's important, or just the number of pictures that we had taken so far, just to know that the things is working as expected. And this is the final result. This is how it looked. So we created this frame, which was a bit nicer than just seeing a regular monitor. Here you can see reflected the window or the building where the event took place, our big button, and here there was hidden the small camera, so that it didn't look like a prototype. It looked more like a finished product. As I mentioned before, Android Things was the core of the whole device. And what is it, Android Things? Android Things is a version of Android which is dedicated to build production-ready physical devices. It's similar to what you are using what you usually use regularly on a phone, but it has some differences. Well, first of all, it has something similar, as I said. It has you can use the Android SDK to build apps. You can use Play services, so all the libraries that Google is providing you when developing an app for phones, you can use it also developing these devices. Android Studio is the same idea that you're using for your phone, tablets, TV. Now you can use it also to build Android Things app, physical apps. And finally, Firebase, which gives us a lot of power, a lot of backend power without having to write any line of code in actual backend development. As I mentioned, though, there are some important differences. First of all, there is no launcher. So when you are thinking about building a physical device with Android Things, you have to remember that the user will not have a launcher. The user is not going to be able to choose between different apps. Your app is going to be run immediately. So it's the only app that is running on the device. Well, sorry. It's the only app that the user is going to see on the device because there can be other apps in the background, but the user cannot choose another app. As soon as you power on your device, your app is going to start, nothing else. there are not going to be system UIs and other system apps that like the ones we are used to in a phone. So for example, you're not going to have the system settings, you're not going to have the status bar, notification, and all this kind of stuff. Also, there is not going to be the Play Store, meaning that the user cannot install another app on this device. The device, when you're thinking about developing an Android Things app, you have to think that this device is going to be shipped with only your app. So it means that you're basically building not only an app, but a combination, a bundle of device and app, which the user is not going to be able to change. Another thing to remember is that displays are optional. So in our case, we were using a monitor connected through HDMI in order to display the pictures, the countdown, and all these kind of things. But in general, a device can only be just the board and some electrical circuits for other input or other outputs, but not necessarily a display. Also, most displays, like the one that we had, are not touchscreen, so they cannot be used as an input. You need to consider different UIs, both to display data to the user, maybe using some LEDs, some lights, or some motors, and also different sensors, like buttons, voice input. You have to think about all the things. So, how do we start developing an Android Things app? First of all, there are several kits which are provided, well, which are suggested by Google. The two main ones are the NXP one, which is the one that I can show you later, and the Raspberry Pi 3. They are pretty similar, as you can see from this picture. And the most interesting part is that the pins that are used to be as input and output are basically the same. So if you already know Raspberry Pi, and you have some of the connections, some of the so-called hats, you can use them in MXP. Another big difference is that the NXP, it has a USB-C cable, which can be used both to power it, but also to develop on it. So if you are going to connect it to your laptop, it's going to appear on Logcat like an Android device. It's like connecting a phone, basically, but it's actually an hardware, a dedicated hardware kit. But then, as I mentioned before, Android Things was born with the idea of creating hardware. It was born with the idea of connecting with other sensors, other input and output. And it allows you to do it in several ways. The most powerful one, but also the most complex, is to use low-level peripheral I/O. So Android Things supports these protocols, which are pretty standard electronic protocols, which you can be used to connect to several sensors. Some of those sensors maybe are available only for Arduino or for other platforms, but if they're using one of those standard protocols, they're going to work with Android Things too. Or you can access some user space driver. These drivers are basically an encapsulation, are a wrapper around the low-level peripheral I/O, but they are dedicated to more specific things. So for example, a button is going to use GPIO, which is the protocol behind. But using a user space driver, you can just call it and interacting like it was a library, like it was a Java or Kotlin object. So it's going to make your development cycle way, way more easy. These drivers, they can be found in a lot of forms, mostly through open source libraries, but Google is trying to collect all of them into a single library, which is available on GitHub. As we mentioned before, we were going to use Google Photos to upload pictures.
Yeah, so where we start, we didn't really have a Java library for the Google Photos. There was only a REST API, and the day before of the wedding, actually they released the Java library. So I was like, yeah, whatever. And one of the problems that we had with this library is that it was not meant to be used without the user interaction. So, for instance, we have a token that only lasts 24 hours. So we need a way to refresh the token. Also, we need permissions to access the pictures and to share them. And this is another thing that you cannot do without the user. And of course, you can only act on an album and on the pictures that you created from your app. So there is no way that you can touch, let's say like that, the collection of the user. So we had to find some workarounds to this, which are in the software part though.
So when to do this upload? Of course, to upload pictures, we needed a network connection. But given that we were in a very nice location, but in the middle of nowhere, we weren't sure that we had any access to a Wi-Fi or a reliable connection. So we used the Work Manager, which is a new library released this summer, if I remember correctly, from Google, which allows you to create and schedule some jobs, some works with a specific set of constraints. So in our case, for example, we were scheduling this job to run after every picture if we had a power connection, which was always true for us, but especially network connection. If at that moment we didn't have any network connection, the job was still just waiting, but the system was triggering it automatically as soon as we get a new connection. As Roberto mentioned, in order to get the picture upload working, we needed the user to sign in to their Google account. But how can we do it if our device doesn't have any input method? It doesn't have any touchscreen, nor a keyboard, anything. We created a companion app. This companion app was a mobile phone app, which allows us to basically allow the user, which was us in this case, to sign in into our Google account, get an access token for the required limitations, for the requirement scopes for picture uploading, and sending this token plus other configuration to the device. To send this data, we used Nearby, which is a technology that Google created to put into communication two devices, in our case, a phone and this physical device, using a set of technologies, both Wi-Fi, Bluetooth, ultrasounds, different technologies, so that devices can find themselves without any configuration. So in this case, the two devices, when they were turned on and close together, they were immediately put into communication, and we could share this data, which was needed to upload the pictures. So, during the creation of this project, we had, and we found also some issues while on the field. The first one being that ambient light was really not something we could control, because after a certain time in the evening, the light was too dark, and so unfortunately, we could not take good pictures, and we could not even turn on another light because the device was outside in a garden. So this is something that, unfortunately, after a certain hour, the device stopped working. Power was also a limiting factor, because we had some power outlets in different spots, and connected to the ambient light issue meant that we couldn't move our device on another location with better light. And I mentioned before, network connection. It's something that we could not control directly. We tried using an access point, which worked pretty well, but still not the ideal solution. We also have some plans for the future, which is basically, well, as Roberto mentioned, to use the actual Google Photos API instead of the REST APIs, so that we are going to improve our code, our maintainability of the code. To solve a bit of the lighting problem, we could just use the full screen as a front-facing flash. Just before taking the picture, we could make the whole screen white, turning at the maximum brightness, and then using that one to brighten the people just before taking the picture. That could work, I guess, when there is low light. Another thing that we found is that Android Things gets its internal time from the network using a network time protocol. But of course, if you don't have any network connection, as soon as the device starts, the date is going to be the 1st of January 1970, which is not great when you are taking pictures and that date is used as a capture date for the picture. So a future improvement is to use a dedicated chip with a real-time clock inside, so that is going to store with a battery the time, and every time, even if we turn off and on again the device, is going to have the right time from the scratch, from the beginning. And of course, the last one is something that I really would like to do to get proper pictures, because I'm passionate about picture, is to use a DSLR. There are several libraries which allow you to connect a proper camera to an Android device using USB and serial communication. There are several libraries because each brand of camera, they have a different protocol. But that is something that I would really like to investigate in the future, for future evolution of the project. So, before leaving you for this talk, I'm just going to leave you some links. And don't worry about taking a picture of this slide, because I'm going to publish the slides on my website. I'm leaving you the official Android Things documentation, links to all the user libraries that user drivers that I mentioned before, a list of nice projects on Axter.io, which is a website for IoT makers, which has a section dedicated to Android Things. So if you want to see what cool projects people have been doing around the world using Android Things, that one is a really good spot to start with. And finally, the whole project we created is open source, so you are more than welcome to have a look at the code and give us suggestions if you see something that we could improve. So thank you very much. As we mentioned before, we are going to have another talk after lunch, this time focusing more on the software part of the project. Thank you. Why RTC, real-time protocol? No, sorry, real-time clock. Time sync is better than transferring time from the companion app with same nearby technology. This is simple, because nearby works if the two devices are really nearby. So in case of an event, using nearby technology would have required me to keep my phone close to the device the whole time. While in an event like this, or even this conference, if we were going to put the booth, the selfie device, on the first floor, and I was going to move away while the device was turned on and off, or just moved, if I wasn't there, the time would have been synced. Because nearby works mostly using Bluetooth, so on the proximity. Having a dedicated chip would allow us to get the real time, even when the device was plugged in and on and off, sorry, from anybody else.
Okay, the next question is, how RTC is powered if there is no connection to power source? Well, the chip that we were looking at has a battery included, so at least for a very long amount of time, it would have saved the time even without the need to be connected to the power source.
Basically, it's the same principle of all desktop computer motherboards. If you ever opened an old desktop computer, I don't know if it's still the case now, but in the past you used to have a small clock battery, watch battery, whatever, which was inside the motherboard. That one was used only to save the time if the desktop computer was moved from one place to the other. And finally, I think it is one we can answer. We can give one answer each. What is the most exciting Android Things project you ever seen? Well, of course, this one. Let me think. Most exciting. Well, the one I was mostly surprised, it was a Braille reader. So it was a reader for blind people, which used some actuators to move up and down some things. I don't know. They were 6, which are they all used with all the combination. You can have all the letters for the Braille alphabet, and allow the blind users to put their hand on top of it and just read, feeling these things moving. It was a really cool idea, in my opinion. Okay, what about programming chips for modules like GSM, photo, temperature modules? For example, for vision, well, again, it depends on which protocol those modules are using. There are, in the user space library, driver library, there are several implementation for, I'm sure, GSM, temperature modules, and humidity modules. It really depends on the protocol that these modules are using. But if they're using one of the standard protocols that I showed you before, there should not be any problem just following the data sheet.
Okay, we have a postcard as well, which is an amazing idea. Could you please recommend some places to buy additional buttons and sensors? Oh yeah, I would love to know that as well. Yeah, where we can buy additional buttons or sensors?
A lot of stores where you can find some devices like this. So where usually they sell electronic stuff, they also have these things. It depends on the country, of course.
Okay, well, this one is a question that requires a very diplomatic answer. So before reading the question, I will answer, and the answer is, it depends. So, how stable Android Things is at the moment? Yeah, it depends. Is it safe to use it for industrial products? Again, it depends. So, it depends because it might be the good solution for you, but for this specific field, there are other options that might be more mature and more stable. So I don't feel like saying yes or no as of today, because Android Thing is more like a general purpose stuff, like Android itself. So it really depends on how you're doing, what you're doing. So if you use it for a more hobby kind of thing, definitely yes. If you're looking for an industrial product, you might want to investigate it further to be sure that you actually pick it because it's the solution that suits you.
Thank you very much.